So welcome to Rhino Carbon Fiber. We're going to be talking about crack repair today. I have everybody, I will unmute everyone during the conference. So if you have any questions or anything that you'd like to talk about, by all means, please jump in. It's good to see you again, Don and Chris from Olshan. Nice to meet you. We're doing crack repair. Now, knowing what I now know, Don should be giving this class. So we have a brief history of Rhino. We give it every time we have a webinar, but basically, we were established in 2001 by Robert Luke Seacrest. Everybody calls him Luke. That's actually Luke right down there on the ground right here. I think he was like 12 or 13 right there. No, I'm kidding. But the basement, Doug, his brother Doug, and Luke, they formed one called the Basement Guys. And they're, in this case, this is one of the fun ones where they had to do a full dig out and rebuild of a wall. So that was fun. They basically were the only full-service basement waterproofing, foundation repair, and basement finishing company servicing Central Ohio. When they opened up the business, they only had 2 employees, and they did about $100,000. And within, I think it was 4 years, first 5 years of ownership, he took a 2-employee company to $4 million in sales and over 50 employees. So it was pretty cool in that way. One of the reasons we talk about the history, though, is that you understand that our company is designed around the contractor first. So the kits are built with engineers, and they're built with chemists, and they're built with other people, but they're designed by the contractors with the end user in mind being a contractor, because otherwise it gets to be, all these crazy pieces and things that don't seem to really work really well in the field. Well, Luke's done it, so he knows how he wanted it done, and that's how he did it. So we were founded May 10th, 2000. In 2001, we adopted Cfrp into the business. In 2003, Advanced Basement Products was formed, and Rhino Carbon Fiber came from that. We have patents in the U.S. and in Canada. The top sill bracket and the connection at the top and the connection at the bottom, those are patents from Rhino Carbon Fiber that a lot of our competitors wish they could do, and some of them we have fun discussing how they infringe, but it's okay. We also have patents on the crack lock. That's worldwide. Literally, I have, not in this particular video, but we have videos of people who are in Australia doing installations of crack locks, and they are genuinely one of my favorite ones to watch. We're Canadian owned by our parent company, AGT Products, in Mississauga, Ontario, Canada, which is a suburb of Toronto, for those of you who know. We represent a family of companies: Drycore, Barricade, Insel Armor, and Rhino. So as a brief history of carbon fiber itself, it was invented in 1879, and it was invented by Thomas Edison. He was trying to make a filament for a light bulb, and what he ended up doing was carbonizing cotton fibers, and discovered they were incredibly strong, but not very good for light bulbs. In the late 1950s, they did some work on it. It's really, actually, the cool thing about 1950s was it was the first application of carbon fiber on a building or on a structure. In this particular case, they were putting it onto a bridge. Now that bridge is right outside of what they call the Swiss Polytechnique, and it's basically the large Switzerland's Polytechnical University, and a guy named Urs Meyer, who pioneered everything that we do in carbon fiber. There was a big delay in time. It was used primarily by the military from the 50s on. In the mid-1980s, there was kind of a change in the way they did FRP, and one of the advantages they found was they had found better and better ways to develop carbon fiber so that it wasn't nearly so expensive for the solutions, because carbon fiber used to be very, very expensive. In the late 1980s, early 1990s, there was a lot of projects that were going on developing carbon fiber for other applications, but the one that we use the most is the one that was done at the University of Arizona here in Tucson, where I live. Oddly enough, both my wife and my daughter go to the University of Arizona. And I found out yesterday that Some of our clients are really well involved with the University of Arizona, having watched some of their projects at the McHale Center. But that being said, the first application was a joint project between UCSD and the University of Arizona. And during the UCSD UC Arizona project, they fixed a bridge in San Diego for seismic, and that kind of launched it. And there were three professors, or two professors and a businessman, Ed Fife and Mo Asani and Hamid, and they all went off and formed a company, and then they disagreed with each other and formed another company. Then they disagreed with each other and formed another company, and so on and so forth. And now there are the five major carbon fiber firms that are in the U.S. all headquartered here in lovely Tucson. And they are either headquartered here or have offices here, being Five Sika, BASF, Rhino, HG3, Quake Wrap, Carbon Wrap, and now there's another one. So there's actually 5 or 7 of us here. But we're all here because the University of Arizona gives us the patent ability to do a lot of what we do. Some of the major advantages using carbon fiber instead of using staples or rebar or anything else is that it doesn't corrode ever. You can put it into a corrosive environment. It doesn't do anything to it. The carbonizing strain doesn't care. It's very lightweight. You're talking about when you're looking at carbon fiber specifications in a general rule, what they'll look at you and they'll say is things like GSM, which you'll see on our specifications. Those GSM indications are generally grams per square meter, so you're not talking about an enormous amount of weight. As a matter of fact, you're talking about the polar opposite. They're very light. They're high strength, incredibly high strength in comparison to steel. A36 steel is 36,000 pounds per square inch. Our lightweight bidirectional is 87,000 pounds per square inch. So it's a little less than 3 times stronger. But the difference is that a square meter of the A36 at 1/4 of an inch will weigh about 100 pounds, and a square meter of our fabric weighs 560 grams. So it's an enormous difference just in that. And it's very durable. Once you put it on and composite it onto an object, it will stay there forever as long as the object it's composited to is still there as well. The most common crack repair that we do is what we call Cfrp confinement or columnar repair. And you'll see this a lot, especially around bridges like you see here. This lovely bridge is in Ohio, I believe. And then you'll see the columnar wrap that's here, and then it's covered with a cementitious repair mortar. We actually now have we have access to a very wonderful elastomeric stucco, which I love because it's UV retardant completely, but it also looks like concrete. Examples of columnar confinement and those kinds of crack repairs. This is a square column, round column right here. This was actually a really cool project in that the cool thing about the project was these bridge piers were put in there. Then an engineer came in later on and discovered that they had been done and that they wanted to put additional seismic on these shear piers, on these piers rather, and so they put this kind of protection here on all of the bases on this specific span of the freeway. So it was kind of cool to watch. We do a lot of slab repair, crack repair in parking structures, hotels, commercial projects like that, where they've had cracking in beams, sleeves, and supports. So what we have in here is like, this is a large slab. I mean, you see the carbon fiber panels that are put on the walls, on the slabs rather, are there to increase the flexural load. This was originally one thing, and then they changed it into something else. And when they changed it into something else, the live loads and the moment loads changed quite a bit. So the engineers went back in and figured out they had to have so much more than we made that happen by adding carbon fiber to enhance the strength of the reinforced concrete that was already there. And as a matter of fact, they put this all together and got it all done. It was fantastic. And then these columns If you'll see here, there are these columns that stand here. We reinforced the columns as well because of the increased load above, but we also had to create these really cool pads that went above on the top side of the slab to reinforce, because the columns themselves became a punching element on these specific columns. These support columns over here, which were much more spread out, not a problem, not as much of a problem. But these smaller columns, they created a punching shear, and they were afraid they were going to punch through the floor when the new moment loads were added. So we ended up doing that. As you see right here, there's also a transition crack. It goes all the way through. We fixed that as well. Another example of some of the cracks that we repair, this is a water tank. It was a 3.2 million gallon tank done in Las Vegas. It was a lot of fun. I loved that project. It was great. One of the best parts about it, though, was that Las Vegas has a really big green footprint, and they really, really are aggressive about it. And they're really restrictive on the amount of water they can use at any given point in time. And so the only water consumed on here, other than the 1,000-gallon tank of emergency wash that we had to have on site for the workers in case they were accidentally splashed with epoxy or other chemicals they needed to remove very quickly, was the water that they consumed. They drank it. So it was very fast. It was very easy. The project itself went really quick, and it was a lot of fun. Another example of columnar strengthening. This is beam strengthening with both flexural and shear. Wall strengthening. This is the backside of a room, a control room in a power plant where they were afraid they were going to have explosions. So we reinforced the wall for blast. In this case, one of the things that we talk about all the time, and something that comes up, is that we are a LEED material, LEED. We're also green and sustainable, so carbon fiber tends to be green and sustainable, primarily because of its lifespan on concrete. You're talking about 25 years, 50 years, 75 years in lifespan without a problem. When we have problems with bridges and things like that, it's because it starts to spall off and crack, and they're having issues with rebar that was aged for 75 years, and it's really not lasting 75 years. It's really only lasting 25. So we were having problems. This is the most common type of crack, though, that we see. It's this spalling concrete that causes a small crack. Now, this is a foundation crack in the top of a stem wall. As you can see, they clean out all the bad concrete, get down to the bare rebar. We spray the rebar with an anti-corrosive once it's been wire brushed and the rust has been removed. And then we repatch it with a hydraulic cement. I recommend we repatch with an epoxy-based cementitious mortar, primarily because there's very, very little moisture content in that. So when you go to apply the carbon fiber later on, you don't have an issue running into moisture on the concrete. Some of the other uses for carbon fiber and cracks are really cool. I mean, people come to us with some really cool, interesting things. I recently did some columnar confinement on the Las Vegas Raiders Stadium. We did some advising on that. We did some advising on the Dodger Stadium. It was a lot of fun. It's amazing. It can be new construction like this, like stadiums. Some of them are new. We did a Georgia Tech Stadium where we were up on the very top of it, and they had some splitting going on in the top, and the guys are rigged up, hanging off the side of the stadium 400 or 500 feet in the air. So it was a lot of fun watching that whole project go up. This is a crack in a fracking station. There's an enormous amount of stress and strain that's put on these walls, and so they reinforce them. You'll see there's a crack before, this is the crack after. We reinforce both sides of the cracks. So, and then they went through and they injected a concrete slurry down into this crack after we built the dam on one side that filled this all up with a concrete slurry. And then once the concrete slurry had set and sealed, then we put another one on the outside. As you can see, the concrete gets all over the place. So with carbon fiber, one of the things that we talk about is the difference is unidirectional or bidirectional. Most of the common ones that we use for flexural that are suitable for strengthening is a unidirectional. Those are ones where the toe goes all in one direction. As you can see here, there's only carbon fiber going this way. The carbon fiber is only going this way. Now, sometimes when you're looking at them, it looks like there might be another one, but these are actually polymer strand. The polymer strand has no strength in it. Now, in our case, our polymer strand is specifically formulated to blend with our epoxies so that it grabs the polymer strand in between the toes when it goes to encapsulate, to assist in encapsulation. So our carbon fiber is actually designed to be able to do that. So it works out really well. This is the columns we were showing earlier, the column confinement and columnar. We use a unidirectional on this one. Now in this case, we use a unidirectional on half of this one, this column, and then there's bidirectional that goes on top of it. Because we had some cracking that we were also dealing with in the tops of these columns where they had some movement. So we did that. We did the repair with the columnar confinement with a unidirectional, and then we used a bidirectional weave on the first layer to give us the extra strength where we needed it and the crack repair capacity in the bidirectional fabrics. Bidirectional fabric means exactly what it says. The toe, that's these individual strands, are called toes. They go both horizontally and vertically. The benefit is that when you have a crack that kind of wanders around, you put that carbon fiber 12-inch strap across here. What you're doing is you center it, so when the strain goes this way, it catches it. When it goes this way, it catches it. If it goes diagonally, it catches it. Carbon fiber loses strength as you come off axis. About 45 degrees, it's about 50% of its strength. So the benefit to having it, another one here that's also at a 90-degree angle, is that it's at 50% strength at 45 degrees, and they blend out and become 100% strength. So you get 100% strength in a 360-degree arc wherever the carbon fiber touches on the compositing. So for cracking, when you start having it go crazy and it moves and does weird things, carbon fiber is awesome for that. This is a great example of one of the crack repairs that we do. One of our guys who did it in sealed, we actually have him in a, we actually have sealed as one of our case studies. If you guys do, and by the way, all of you, I recommend this highly. Don, Stanley, Chris, when you guys are doing these kinds of projects and you see something that's really cool and you're like, ooh, this was a great application, photograph it while you're doing it, photograph it after you're done so that we can get all that information together, and we blend them together, and then we build case studies for Rhino so that when we go to trade shows and events and corporate shows and things like that, like ACI and ICRI, we can present those things there. And we, as you can see, we put your logo on with your contact information on it so that when people see it in their market, they know, hey, you're a carbon fiber expert. This was a really cool one because as you can see right here in this giant pile of stuff, this is all epoxy and it's silicone and it's whatever random other stuff the homeowner had just kept cramming in there over time to try and seal up this crack. And so what we found was that they went in there and Randy they tore it all out, got it all cleaned up, got it down to bare concrete, and then they patched it with concrete. Then they did the injection, came back, knocked off the ports, put a crack repair fabric system over it, as you can see, sealed it all up and encapsulated it. And when they were done, it looked like that. And then he painted right over it and disappeared. So they weren't even aware that the crack was still there. He was really happy with the repair. But what we get is structural repair across the crack. The crack is filled. The crack is also injected. And so this is our good, better, best approach. Our good approach is to inject it. That's good. You're going to get the best you can get for 3 to 5 years. That crack should be nice and steady and solid. The problem is that as soon as those stresses that cause the crack start to move the wall again, you'll have stress issues, and those stress issues can cause all kinds of other problems. And so when it does, it starts to open your crack back up. So you don't want to open your crack back up. That's why we use the crack repair fabric over the top. Another option to use is a concrete crack lock stitch. I would normally at this point play a video, but because I can't tell you what everybody's internet speeds are like lately, we don't play the videos, so we'll skip it. But as you can see, there's a video on how to install it. I can turn it on really quick. And normally we would just show you those because they're a really good example of how it works. But unfortunately, with everybody's internet speed being kind of hit and miss, I didn't want it to stagger and lag on you guys. So this is one of the products that we frequently compete with in the market. Now in this case, it's in pools. It's called Torque Lock. One of the things we love about the Torque Lock is that it's a labor-intensive process of love. There is no doubt. You have to groove out the entire channel or the entire crack on both sides. Then you have to mark out where the torque locks are going to go. And then you have to cut the steel down to size, drill holes and post it, chip out these wells, as you can see these wells. And then I always laugh when they do this, and I know this is not cool, but here's the thing. He chips this all out, does all this stuff on this demonstration, and while he's doing the demonstration on the video, he torques it down and it cracks again right here. He then torqued it down and cracked the plaster, and he cracked the gunite shell again. And then they go back in and they repair this with plaster, and he calls it a repair. And the problem is the crack goes here all the way through, and then each time he pins in here and puts torque on it, it cracks. Another crack right here, the crack is right here. Each one of his torque locations cracks the concrete anew. So it's just, I don't like this repair at all. As you can see, what they'll do is they'll cut out these big channels. They'll put down bolt legs that look like this. They go down in there like a staple, and then you apply a torque to it. And the problem is that concrete only has a fixed amount of compressive and tensile strength it can give you. Now in pools and pool environments, and I own a pool, it's in my backyard, and it has 6 crack locks in it right now. But one of the weird things about pools is that when you fill them full of water, they go into compressive intensive load almost immediately. The water spreads out and disperses its load very evenly across a large surface, but what can happen is across that large surface, you get pockets. You don't get pockets where there's force concentration. Water distributes its weight equally and evenly across the entire plane. That being said, if you take away some of the compressive and tensile strength because you're torquing against it, there'll be weak spots around here. So if he torques this to a specification, I don't know what it is. To be perfectly honest with you, I don't know. But if say the concrete has, this is 5,500 pounds per square inch of compressive force in it, and it has, in that case, it would have about 600 to 650 pounds of tensile capacity, and he torques this thing down to 100 pounds per square inch, whatever he torques it down to. You're missing all of that tensile strength whenever it goes to move. So when you load it with water and everything else in the entire pool is going to register 650 pounds per square inch, except for this one weakened spot. It's already starting to crack. So it's going to come back. Not to mention the fact that you steel in a corrosive concrete environment, it's going to fail. This is a bent steel rebar. A lot of you guys have seen this before. I guarantee you most of you have used it at some point in time because it's a very convenient, easy, fast fix. The problem with it is it's rebar that failed in here that caused the crack. It's rebar that's going to fail again to cause another crack, so you're going to have an issue. Carbon fiber staples are the other thing that's really, really popular. For a long time, carbon fiber staples were pretty awesome. We used to use them. We have them with our Rhino, but we don't use them very often. So this is actually Luke's garage where we were testing one of the original staple schemes. As you can see, when they painted over it, it's very hard to find them. Now we know where they are because we can see the crack here. But the first coat over them with an epoxy, it was barely noticeable when they were done. And the second coat, they did a flood coat after that. And as I've been told, you can't see the staples in there at all. This is actually a staple application, but we're using crack locks for this application as well. When they're piering, lifting and piering, they're having an issue with lifting and piering, and all of a sudden they'll see where they're going to go to. They have to put a footer because of the design. When they put those footers down, they'll use the crack locks to reconstitute the footer before the lift, so that if there are cracks in it like this section was, then they'll just lift it once they put the crack locks in and it's done. They don't have to worry about the repair. They don't have to worry about this piece buckling later on. It'll never move again. And these are the crack locks. It's a much faster installation than a staple or pretty much anything else. I wish I had somebody on here from one of the companies that we'd done the training with, but one of the companies I did the training with in Olathe, Kansas was hilarious because I actually asked them who the person who had the least experience with any kind of tools at all, power tools or anything else. And they sent me out a 70-year-old accountant who had 5 staplers on her desk because she kept breaking her staplers. So we were comically laughing about the fact that she kept breaking her staplers. But we brought her out there, and it took her 8 minutes to do an installation. 8 minutes. And 1 minute of that, I will be honest with you, was spent chasing a concrete saw because somehow when she picked it up, she hit the lock on it. So when she hit the concrete saw off the ground, it scared her. She let go of it, and it went shooting across the warehouse. So we spent a minute chasing after a concrete saw once it hit the end of the extension cord. So it happens. This is actually in Australia. This is one of the Ardex companies, one of the waterproofing companies in Australia that we work with. One of the things that we love about it that I thought was super cool was that they do a lot of this concrete crack repair, and they didn't have a product or anything at all that could really work for it. And so we were talking with them about what they could do, and they weren't even warrantying their cracks at all. None of their cracks were being warrantied. None of them were even being set up as if they could do it. They were like, yeah, if we do a crack for you, the repair, it may come back, it might not come back, but this is the best that we can do. Now with crack locks, they actually offer a 5-year warranty. They have 5 years, that crack will not move, it will not reappear, and it will not re-crack, which is something that's very easy to do with the carbon fiber crack locks. It'll stay in there forever. The only thing that you have to consider with is, in this particular case, as you'll see, they're slightly recessed down, and what they did was they got it all down in here. They got the carbon fibers sunk, and then they put in the epoxy coat to fill in the crack. And they cast number 60 playground sand over the top. That number 60 playground sand had a major advantage in that it caused a great biting surface. And then they skim coated over this with concrete. You couldn't even see the repair when they were done. For those of you who are into doing commercial contract work and civil work and heavy work, this is actually the Ohio DOT. They had an off-ramp that they had just put in. As you can see, it's nice and pretty virgin concrete. It hadn't really been driven over that much. But in the testing phase, they were driving a large truck across it, and they cracked the deck. What they found out was they were having an issue with the amount of force they were putting into the road was force concentrated in an area. So they went back in and they filled the back up underneath with an injectable polyfoam. I believe that job was actually done in conjunction with one of our contractors who also specializes in doing Eurotech and polylift. But this one actually has 4 crack locks in it. There are 4 crack locks in each one of these locations. And what they did was they put them down, one all the way down at the bottom at 8 inches, then up at 6, 4, and 2. And then the other ones are buried. So there's 2, 4, 6, and 8, and all the way down to the bottom. And what it does is it creates a multiple planes of force. So when the moment changes, it grabs at different places. And the greater the moment, the more it grabs and moves. Well, then there's more crack locks that engage. And they're at 180,000 pounds per square inch of reinforcement. So what we really did was we added 4 times that amount. So what, 720,000 pounds per square inch on each one of these holes. So there's 750,000 pounds per square inch of tensile reinforcement represented by each one of these holes. So it really made a huge difference in this. And when they were done, as you can see here, they were done. They came back over and they reprofiled it and resurfaced it. This was right before they did the resurface, and you can't even see where the repair was. Going back though, I wanted to notice something on the other slide. I wish you guys could raise your hand and wave. But see this thing called a Tough Wipe? I love these. Even if you think yourself, you know what, I'm a waterproofer and I do some carbon fiber, but not a lot, I recommend this thing right here. The Tough Wipe is cool. It's an organic, non-toxic, an organic chemist created a solvent as an organic solvent. And the cool thing about it is you can do it with your bare hands. You can wipe things with your bare hands. It won't hurt you. It doesn't eat plastic. It doesn't do anything harsh. Unfortunately, I have tasted it and it tastes horrible, but it won't kill you if you accidentally ingest it. I don't recommend it for anyone, but yeah, I mean, you may have gotten Tough Wipes on your hands and then eaten food. That could happen. But the tough wipes are really cool. I love them. Methylcrylates, polys, epoxies, grease, dirt, very hard to get off stuff. We get it off easily, and the tough wipes are the best way to do that. As you can see, they're using tools here to scrape stuff in, and what we're using is tough wipes to clean the tools off so they can go back to use the next day. This was actually a really cool one. It was this crack actually involved an addition to a house, and when they went to put it together, they did stitch it together with rebar on the inside, but later on I'll show you a picture on the outside of this addition where the addition was pulling away from the house, and the reason it was pulling away was because the outside edge of this, way off to the edge of this this walk-in basement where they put this flooring, way off to the edge, it started to tip, and they had some differential settlement that actually pulled, and this piece actually undoweled itself and slid, so it opened up. So we fixed it by putting it back in place. The spacing is a little bit different because the engineer that we had that we were dealing with, that engineer actually came back in and put it all back together and said, you know what, how about we space them every 6 inches instead of every 12 so that I can get a little bit more reinforcement in here, and that's exactly what they did. This is actually an expansion joint that you see right here. And what they did was the engineer came in there and did a designed expansion joint with a control cut that's a little bit further up and a little bit further down. Then we went in and fixed this. But the reason they had this was because this open window right here was creating an advanced thermal pocket on the floor. So the concrete right here was getting heated and cooled much faster than the surrounding concrete. And so they were getting thermal differentiation. And unfortunately for everyone, and this is true with carbon, although not nearly so much, the rate of expansion and contraction in thermal differentiation between steel and concrete is significantly higher than it is between concrete and carbon fiber. So the carbon fiber can expand and contract with the concrete much better than steel can, because the steel has a much different compressive contraction rate. So when you heat it and cool it, it expands and contracts at a much different rate, which is what caused this huge crack right here before they went down into the basement. One of the most common applications for us is that people who do decorative overlays. In this particular case is a gentleman who's out of California, and he does very high-end pool decks. I was very fortunate in that I got to meet the artist who does these stamped stone inlays, and they they hand paint and arrange all of these things using a specific kind of dusts and pigments and paints and things. And it was super cool to learn how that all worked together. And I legit spent my entire lunch sitting on one of these planters watching this 80-year-old guy come up with a little cart, and he would push the cart up and stop, and they would grab a handful of pots, these little pots, and he would sprinkle and spray and paint and do things to make all of these little stone flagstones look equal. But the thing is, these overlays are very pricey. You're talking about, this one is $250,000 overlay that goes across the entire of this Olympic pool-sized area, and they couldn't guarantee it. They wouldn't warranty it for crack because the entire thing was massively cracked. And so we put crack locks in, and then they put an overlay on it, and they warranty it, and they give it 5 years for cracks. So in California, that was pretty awesome. Now, just so you think that an engineer won't get in there and occasionally cause you to have all kinds of fun, what he did, this arrangement that you see, this four crack lock arrangement, is different because what's difficult to see in this picture was the crack starts over here and then it arcs out like this, and it arcs all the way back to the other end of the pool. And so this whole top of the slab on the curtain, because there's a cutout that goes underneath to here, because they have an invisible rim, a rimless pool, so it actually goes down, and then there's a waterfall and it collects all the water inside this little channel. But there's an overhang here, and there's these diving boards that used to be here for the racing lanes, and over time these boards had created so much stress they started cracking the concrete around their anchors, and so there was a crack that started, and it literally went in this giant kind of half moon shape all the way across the pool. And so the engineer wanted to change the way the concrete reacted in tension, and so he created this pattern. And as you can see, this is how they put it down. They built a template out of plywood. They actually built a few templates out of plywood, and then they cut it all up and did it. Well, we went out there and photographed them while we were doing it, this is in California, so you know there's 100% silicates recovery. I would have hearing protection on and a mask, but he doesn't, so that is what it is. But anyway, they came down here, they were laying arrange them out, they set them up, and they look like this when they're installed, and this is what the job looks like when they're done. Now, here's the cool thing that I think most people don't realize is that you can't see the repair. As you can tell, you can't tell that the crack was right here and went all the way around here and all the way back to the opposite corner. You can't see it because the crack locks are a subsurface application. Whatever you want to skim over the top will fit. So you don't have to worry about how it's going to look to your client because we can make them subsurface so that you can skim coat over the top of them. As a matter of fact, I was just recently talking with the University of Arizona because I was there with my daughter and my wife, and we were walking around doing a bunch of stuff during the walk, and we were talking about some of the repairs that they have in the concrete that are there, where they have overlays with decorative overlays that have the U of A symbols in them and things, and they are cracking. And I said, you know what? I know a company who can come in here and do the overlays, and I know a company who can come over and do all that stuff for you, but let me, you know, we're going to donate some crack locks to your cause here for your logo. And then we went in there and did some crack locking over there to hold it all back together so that when they did these decorative overlays, which are really expensive, I didn't realize how expensive they are, for the Wildcat and for the overlay for the U of A, they won't ever crack again in that area. So it was really cool. As a matter of fact, one of the gentlemen here sitting in our class today actually did some massive amount of repair on the U of A. So we'd like to thank him for that. McHale Center is a much safer place because Don did his work. So this is actually a really good example. This is a Pebble Tech is what it's called, this shell that's on a pool. But as you can see, you remember the torque lock installation, it was all tore up and they had to do a bunch of jackhammering and a whole bunch of removal, and they had to go down into the gunite. And once you got to the gunite, you had to tear out these huge pockets, chase all the crack and do all that stuff. In our case, it's literally drill 2 5/8-inch holes, cut between the two holes, and then you just run it down. And as you can see, there's one of them actually slotted in here and installed, slightly subsurface. He's got it slightly recessed, and then he filled it up with carbon fiber and he'll fill it with carbon fiber and then top it with the exposed epoxy. Then we chase the crack with epoxy and you're done. In his case, he had it, we arrested it. So if you see, we stopped the crack here, and here it stops here. We actually went a little bit further than the crack so that it would arrest it in case the crack moved just slightly. When it did it, it'll go down and there's another crack lock, it stops. But we got really lucky because as you can see here, this crack goes here and it's mirrored on the other side of the pool here. Before it translated through the bottom of the pool and they connected, which would have caused the pool to become a demolition risk. They would have had to tear the pool out to repair it. We get in there with the crack locks, and then when they're done, it looks like this. So if you would like to show me the crack locks, I can tell you the crack locks are here. They're right here. But I only know that because I know where the jet is. The jet's right there, and the jet's right there. And I know that 3 feet away from the jet, there's a crack lock. But honestly, there's nobody who would ever know. I have 6 of them in my pool. In much the same case, they're right off the bottom beam and they go all the way down the side of the pool. And in my case, you can't even see them at all because I buried them in the gunite. And then I replastered that area with gunite, and then we had them replaster my pool with quartzcape. You'll never know they're there. Another kind of crack repair that we do that's really, really frequent is a corner repair. Now, in this particular case, we're going to skip this video, but you're welcome to look at them on YouTube. We have a Rhino Carbon Fiber Rhino Carbon Fiber YouTube channel, and you can go in there and just look up Rhino Carbon Fiber crack lock and Rhino Carbon Fiber corner repair. If you just look up Rhino Carbon Fiber, you'll see our YouTube channel. It's pretty cool. This is a corner crack repair. Now, I will tell you this is an unusual repair in that the engineer specified them to be every foot. So if you see there, this is an 8-foot wall. We don't normally have 6 straps on an 8-foot wall. But their spacing was such that because the humongous load that's on the other side of this wall that was causing separation. But as you can see, they had to retuck the entire corner. So this mortar joint this mortar joint all the way down the wall, this mortar joint, this one. It literally was pushing this whole segment of block off the wall and opening that corner up. So we reinforced it that way. And this one looks nice and pretty because they did a two-man job, and the way you do it is you lay it out here, and as you trowel, gravity is not your friend. So we have this stuff called Gorilla Tape. It's not ours. We buy it from Home Depot just like you do. Actually, we buy it from a distributor and get it that way. But the Gorilla Tape is awesome because you can put it up around where you're going to put it, and it's epoxy proof. Gorilla Tape is not affected by epoxy like duct tape, masking tape, things like that. They can be affected by epoxy and cause them to lift. So you put Gorilla Tape on here, and then when you're going along, you have a pocket full of Tough Wipes in a little plastic bag, and you take them out and make sure as it starts to drip, you rip it off with the Tough Wipes to neutralize the epoxy, and it doesn't stain it. So you have it only on the places that you want, not where you don't. This is another kind of crack repair. This is very frequently done. This is a commercial building. They were going to have to tear it down because the outside corner of the building was actually going really bad. As you can see, some of the surface preparation that they did for this crack was what they actually went through. They had to retuck a lot of the mortar joints. They did it retucking. I don't think they didn't rake it. They left it proud. And the reason they did that was because they want to have a flat surface for the carbon fiber to go onto. So these mortar joints normally would be tucked and raked, but they aren't raked. So, you know, that's what they did. They left it like that. Then they did surface grinding. They take it down to aggregate level to expose the pores, vacuum the walls. Do not use a blower. I tell people all the time when they do these installs, the single largest problem that we have is surface preparation. There's actually a study that was done at the University of Texas that shows that 99% of all failures in epoxy system application. It also counts for polys. It also counts for methyl acrylates and things like that. The single largest is surface preparation error. Since you have surface preparation error, then what you're really looking at is that surface preparation has caused a failure in the epoxy. The largest contributor to that for a long time was that you failed to open the pores of the concrete so it doesn't have an adequate bonding surface. What I recommend in that particular case is always use a vacuum to suck all the dirt and debris that you've ground off this thing out of these pores and open them up. Then I also recommend that you take a spray bottle with just plain old water, everyday water, and spray it in certain spots on the block to determine whether or not there's grout lock, hydrolock, some kind of waterproofing material that was forced into the entry in between the pores. Do something like that. Because that way when you're going to apply it, the epoxy will not bond to a surface that has had a waterproofing membrane put on it because there's nothing for it to bond to and just sit there. So if you have grout lock or if you have hydrolock or if you have some kind of lock on there, whatever it is that you're using, then there's that problem. Then you definitely want to make sure that you know it. So I always recommend bringing along a small spray bottle with a little bit of water and mist it on the wall. If the wall is open and the pores and aggregate are open and everything's ready to go, it'll blow right into that wall. It'll evaporate away. You'll never see the water very long. It'll just go straight into the wall. That'll evaporate away in 5 to 10 minutes, so it's not a problem. But you want to make sure that you're sprinkling it on there every once in a while, because if you have somebody who's got Invisiprimer, like I said, or Hydrolock or something, it'll just damage it. It'll make you have a bad bond. So they chased the crack around. They did a crack repair fabric, which is a 12-inch wide fabric. It's also bi-directional. They laid it up there across the building. As you can see, he put his little security camera back up. And then these straps are laid out per an engineer's specification. But as you'll notice, they're much, much longer. Our standard corner strap kit is a 10-foot kit with 5 feet on either side. As you can see in here, they actually go back quite a ways. It was because of the level of stress that was on this wall, some of the seismic requirements, some of the unique requirements for that specific jurisdiction and things like that. And that's how the engineer set up the repair. As you can see, they didn't go back through with a tough wipe and clean it all up. So it'll start to drip. Gravity is not your friend in that regard. So make sure that you're putting it on there, putting it into the straps, using the encapsulation and the skills to get it done. but also clean it up a little bit. That's why we recommend having tough wipes. We give them out to our crews. Typically what you'll do is you'll take a tub of tough wipes. You'll put that big tub of tough wipes in a Ziploc bag so that it stays in there nice and sealed, and so that if somebody accidentally tips it upside down, rolls it over, does whatever, it doesn't leak. But put it in a Ziploc bag and then open the Ziploc bag, take out 4 or 5 wipes, put them in a smaller Ziploc bag, stick that bag in your pocket, and then as you're going throughout the workday, when you notice you've dripped a little bit, go reach into the bag, pull out a wipes, wipe down what you need to wipe down, put the wipe back into your bag, and then just keep using the same wipes over and over and over again. And those 4 or 5 wipes will last you all day. This is the repair after it's been painted. Again, you can see some of the drips and things like that are on here. But you can barely see the carbon fiber, as you can see when you're at a distance. If you're up close, you can see the edges of the carbon fiber encapsulation. But I mean, it's a really good job. It hides itself very well. It tends to be a block height in there, so it's right blended into the block pattern anyway, so you're not really disrupting it, except for this long pattern that we had here. But again, we know where the repair is because we saw it when it was going up, so it's pretty easy to understand. Again, another video that we talk about. I love these videos, by the way. We're going to skip it. This is actually an engineer who was talking about it. He was saying, okay, there's a crack in this house, the crack in this window. This was actually, again, the addition we were talking about earlier. The original structure was here. They added an addition to it. When they were adding the addition, there were some problems. He puts RFC, he means RCF, Rhino carbon fiber, for what we're doing it. But the engineer came through and he set all this stuff up. And it was really, really cool because while we were doing all of this, they were like, oh, well, how do we fix this other thing? And so that's where the crack locks came into it. So we gave him a multi-pronged approach. As you can see, there's the addition, but on the other side of the addition, they had cut this window out. We actually have a kit where you can, when you do window cutouts or penetrations into concrete, called a hashtag or a portrait. And what you do is you frame it by going 6 inches down, and you go 6 inches around the window, around the window, around the window, around the window. Then you let that composite for 6 days come in and make your cut. What that does is called preload or pretension the window. So when you go to cut the window opening, you don't have that break in tension across the window plane where you no longer have reinforcement or structure. And so it basically creates a header or a lintel to hold and carry that load across. And then as the stresses and strains try and make the window move where you're missing stuff in here, obviously all the concrete block that was in that hole is not there. When you do that, what you'll notice is that the window itself goes kind of out of the picture, and then all the stresses and strains are caught by the carbon fiber that reinforces it. And this is the outside of that. As you can see, where these two structures were put together originally, they had this thing, and then this started differentially settling, and this whole house started moving apart. And so, as you can see, there's a doorway, and there's this crack that went all the way through here, all the way up into the addition, and then from the addition down, it came here, and then there's this another slab floor, and there's a slab floor here, and there's some hardwood floor in here. And where it started to slide away, we fixed the hardwood floor from slipping around using crack locks. We fixed the building from falling apart using a specific design. And again, they can come through here before the epoxy cures. They could have used tough wipes to clean all this up and make it pretty for the customer, but they parge coated over the top of it, so it really didn't matter. Common repairs that we see in the industry are these stair step cracks that come away from windows or go towards corners because you're having some torque on the wall. In this case, my guess would be that they didn't pre-stress that opening, or there's insufficient support on the opening, and so this wall is actually flexing a lot more, and so you'll get these cracks. Now, I will tell you the number one question that we get is, will I ever have cracks in the wall again? I can't tell you that. Nobody can tell you that. But the odds are very good that you'll have cracks again, but it won't crack underneath where the carbon fiber is because it's massively restrained and reinforced. So again, here's my favorite towards the end of the discussion, we talk about these. Cleans tools and hands. As you can see, he's cleaning his bare hands with them. It's very easy to clean your bare hands. We clean our tools off with it. It takes the epoxy off the tools and saves you a ton of money on tools. I have a gentleman who's in Northern California who does striping on roads with a methylcrylate, and he orders a pallet of these every quarter. The cool thing about ordering a pallet of these every quarter is that those pallet loads can cause you to have reinforcement, or not, I'm sorry, to cause you to have a ready supply on hand. And apparently methylcrylates are super sticky and super complicated. So we try and make it so super sticky, super complicated is easy to fix. Just throw a Rhino Tough Wipe on it. Hands, tools, and surfaces, takes it right off. It saves him a ton of money because apparently he used to have to replace a bunch of hoses and a bunch of other things because the methylcrylate gets on it and causes damage. Starts gumming up the works. So we have a way to solve it for him. This is actually roofing tar. I know this because I just took it off my tools, but I also took it off my driveway. This is an epoxy mix where we actually had somebody bring in an old gun and we cleaned them up with a tough wipe. Some of our guns are orange. The company that has a big orange sign on the front of it, we get our guns from the same place, the same manufacturer. Our guns are $30 each. Their guns are $62 each. So if you ever need one in a pinch, you can go buy it from that big orange place too. Although, like I said, ours are only $30, so I don't recommend it. One of the things that we like to leave off on our support is our support. And I think that this is something that Rhino sets us apart from our competitors on a regular basis. I know, Chris, we've dealt with Olshan and given them very, very specific sell sheets with logos on them and stuff like that. Those animated presentations, there is a fee involved if you want any of the animated presentations or videos to have your logo on them. But it's because we don't build the videos and the animated presentations. They're done by a company for us. And so if you want to insert your logo into them, I think there's a fee, and I don't remember how much it is. I want to say it's like 500 bucks, but you're not paying the $7,000 to have them all developed and ready to go. You're just paying 500 bucks to get your logos added to it at key spots throughout the entire place. Your logo, name, address, phone number, all that fun stuff is in there. So those are animated presentations. We have sell sheets to help your salesmen or for your contractors, especially commercial guys. We have case studies where you can talk about something that's very similar to the application you're talking about. We have case studies on the Georgia stadiums. We have it on the University of Tennessee, case studies on all kinds of stuff. Really awesome array of business. We have a case study of the project I ran on Mauritius Island, which is out in the middle of the Indian Ocean. If you're curious, it'll take you 32 hours to get there if you want to fly. So, make sure you pack a lunch or fly on Emirates Air because they feed you 5 times during the flight. Those are case studies. There are pull-up banners as well for when you go to home shows or when you're out and about. I recommend also having the pull-up banners there out in front of places where you are when you're showing, just because it draws attention to you. The videos which we were talking about, application instructions. Every single kit that you get will have the application instructions for it, but if you don't have one for some reason, they're in PDF format on our website. You literally click a button, you can have them on a cell phone, tablet, or something like that. So if you have a foreman who's out and about and he's got a question about an application and he doesn't have the instructions with him because one of the other guys in the crew has taken it and they accidentally threw it away, or they got it wet with epoxy and it's now smeared into an ugly gray mess. Whatever happens, they're always available in digital format and very easy to access. We have technical information on our website, also free and easy to access, TDS and SDS, technical data sheets, all that stuff that we need about it for engineers to be happy. Apparel and giveaways are awesome. We have Rhino carbon fiber logos, logoed polos, koozies, beer bottles. The thing that everybody loves at our shows recently has been these little Omni tools that have like a little measuring device on them, a little small box cutter. It's about the size of a credit card. It will definitely get taken from you as you go through TSA since it's made out of metal, but I like using it more than anything else in conjunction with a tough wipe because you can dip it into your epoxies and pull it out and it's like a depth gauge. You can see how much material you have on the substrate up. So if if this is how you work, you want it to be a 15 to 20 mil base layer, 45 mils of encapsulated carbon fiber, and 15 to 20 mils of top coat. it's really easy for you to add those things together and get to that 80 mil capacity, but it's really easy for you to just stick it in there and go, hey, you know what, there's a little too much carbon, there's a little too much epoxy on the base layer, spread it out a little bit more so that you know how much you're using. But that's one of the great things that I use it, and I use it for that all the time. We also have giveaways all the time. If you go to trade shows with us, we give away bowing wall kits, carbon fiber, injection kits, poly kits, all that fun stuff. And then there's so much more that we do all day, every day. These webinars are a good example of one of the things that we also do. We do customized training for you. If you have a specific application you would like for us to research and go into, we can then do customize those things. I have a training session later on today with a company that we're going to be doing large silo renovations in Northern California, where we're doing these large silos, and we're going to talk about how to lay out 25-foot long straps, how to do all that other stuff. So it's really, really cool to do that, and I love that part of my job.